Good morning everyone, I am Mr. Ish. We're looking here at a trigonometry algebra single question video, but the question will be in two parts because I have it indicated such we have to find points of intersection for these two functions sine x and cosine x, but we have to do it via the graphic procedure, which we can call the trigonometry way, and then we have to do it by the algebra procedure. We can call that our second question of the video then. So let's look at it here in terms of part A, but let's, before doing that, understand the fact that this can be slightly challenging for some students and for others it may not be, but this is perhaps a good level of question for any 12th grade math student or advanced math student in their high school, even trigonometry students. For a function f of x is equal to sine x and cosine x, we have to find all points of intersection. What does that mean? You know, when you have two specific lines or curves, generally lines as we're speaking of when we're talking about high school math, when you do the intersection of those two lines, you have a point which is present on both lines, which means those are the values of x for which both equations will be equal to one another. So in essence, we're basically finding graphically and algebraically this specific situation here where at what value of x is sine and cosine function the same. But let's look at everything here with the graphic approach first. And if you're not familiar with the sine and the cosine graphs, let's make you familiar in this video. We have everything here from positive 1 to minus 1. We have the origin here, and then we should ideally go here by 90 degrees. Pi over 2 pi, 3 pi over 2, and then we can say 2 pi. This right here is 90, 180, 270, and 360. And then likewise we can have the negative versions of these same angles. I won't list them out, but this would be minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. The main thing you have to know about graphing the sine and the cosine, sine goes here to the origin, but cosine of 0, it goes here to a y-intercept of 1. So let's actually, you know what, let's focus only on the sine first and we'll superimpose the cosine on top of this. Sine of 90 degrees is always equal to a 1. Sine of 180 is a 0, sine of 270 is a minus 1, and sine of 360 is a 0. And then you connect these dots. Remember, we don't have to be ideally perfect here. But sine of minus 90 is a minus 1, sine of minus 180 is a 0, sine of 270 is a positive 1, minus 270 is a positive 1, and minus 360, these are my negative sides, that's a 0. So I will continue the sine function like this. This right here is my sine curve. Now let's superimpose the cosine curve. Cosine of 0 is always a 1, cosine of 180 is a minus 1, cosine of 360 is a positive 1, cosine of 90 degree angles are always 0. So 90, 270, minus 90, minus 270, they're all zeroed out. Cosine of minus 180 would be a minus 1. Cosine of minus 360 would be a positive 1. Right over here. So now let's connect these dots. We'll come out like this right here and here. That's my cosine, and then we're coming here and we're connecting here. Now the points of intersection are those areas where sine and cosine are equal to each other. Here's one point of intersection. Here's one point of intersection, here's a point of intersection, and here's a point of intersection. We have to find these, and then we can always extrapolate beyond that for the minus infinity to infinity domain. Always looking from minus infinity to infinity. This right here is a value between 0 and 90. This here appears to be a value between 180 and 270. This right here is a value between minus 90 and minus 180. And this here is between minus 270 and minus 360. If you look at these rough generalities, we find out that the good intersection point always comes after every 180 degrees. So if we can figure out this one, we can always do whatever this might be. Let's just call it x. Then we can always say plus or minus pi n, because pi is 180 degrees. Whatever this first value of intersection is, we'll write that here. Then we'll do plus and minus pi n. That will cover all of these intersection points to the right and to the left. And with that, we will have our good intersection developed over here. This right here is a graphic approach. The graphic approach, without having a good software and having accurate drawing, it's very hard to judge what this is. I know in my mind what it is, but we have to show you. So from the graphic approach, we've determined this. This right here is the answer of part A. We will add into this answer by first looking now at part B. The part B is we have to do algebraic determination now of this intersection point, and then we'll put that value over there. Now for part B, we'll look at the algebraic determination of this value of x, which will then easily plug in there, and we'll complete this entire question. We have sine x is equal to cosine x, because that's what we're looking at, the value of x for which both sine and cosine are always the same. Your next step should be to square everything out, because we want to bring everything here in terms of a trigonometric identity. Sine square x is equal to cosine square x. Bring it on the other side. Sine square x minus cosine square x is equal to 0 because there was nothing left after you moved the cosine. We have a trigonometric identity which you know. Sine square x, I'm abbreviating it here, plus cosine square x is equal to 1. You can solve for cosine square x is equal to 1 minus sine square x. Right here I can substitute this 1 minus sine square x. Sine square x minus 1 minus sine square x is equal to 0. Open everything up. Sine square x minus 1 plus sine square x is equal to 0. Take this 1 on the other side, combine the sine square x. We have 2 sine square x is equal to 1. Sine square x is equal to 1 over 2, and then sine x is equal to the square root of that, which is plus and minus 1 over root 2. And then x is equal to inverse of this. Now we have to look over here and let's do 1 divided by root of 2, positive value, and inverse sign it, and we get 45 degrees. Our answer here is 45, which I'm writing as pi over 4. We could always look at that negative value and then we'll find out that we can do 1 divided by root 2, and then we can do a minus of that and inverse sign that. We'll get a minus 45. But the problem is minus 45 will not fit the bill because as you were seeing with those graphic intersection points, the minus 45 degree angles will just not work. Think about it like this. 45 minus sine, I'm getting a minus 0.707, but I do 45 minus and I cosine, I'm getting a positive 0.707, so it won't work. What's your answer over here? It's going to be exactly this. You'll have pi over 4 plus and minus pi n, and these are all the values for which both the sine and cosine will be the same. If you add 180 in the front of this, from 45, another good value will be 225 degrees, right? Think about it. 45, 225, the next 180 degrees. Then from 45 you can go backwards by 180. You can do 45 minus 180. Another value would be minus 135. And then you can see from this value expression right here, you can easily determine all the values for which sine and cosine are always equal over this infinity domain. And with that, we bring this question to an end. Thank you for watching. Have a nice day.